We're now in Dcad lesson 18C, continuing with project evaluation. And we'll actually be doing some design work, some structural calculation stuff in this lesson, but we're continuing to evaluate the project because we're still looking for something that might stop the project, something that proved to be insurmountable structurally or something like that. So at this point in time, we know that we're okay with the standard yard setbacks, front, sides, and rear. We've gone through the City of Ashland solar setback calculations, and we've determined that we're fine there. So now what we want to do is take a look at some of the structural considerations that we're going to be dealing with, because it's always possible that something is going to be so expensive that the project just isn't worth it. So at this point in time, I'm going to go to my projects folder. D0604 is our actual specific project folder. I'm going to click here on D061 for W1A2. That's the PDF drawing for the garage that we were fortunate to obtain. Actually, we had it because we drew it. But anyway, take a look at this floor plan here. We might be looking at a section drawing also, just to get an idea of what we're dealing with the existing garage. So I'm just going to enlarge this a little bit here and pull it down. So we know that parallel with this garage door header, our garage is 24 feet long, and perpendicular to it, we're 22 foot deep. So typically, one of the considerations that we're dealing with initially has to do with this existing garage door header. And note 42, let me just take a look over here and see how big that thing is. 42, it's a 5.5 inch by 13.5 inch 24F V4 visually graded Western species glulam beam. So, and that was designed to support roof loads. So one of the things that we're going to take a look at is, well, we're going to be adding an upper floor, and so there's going to be some kind of floor loads out here, and depending on which way we run the joist, that could adversely affect this existing garage door header. So typically we would try to run the upper floor joist in a shorter dimension, because it's less length, less span, less load, all kinds of good things. But if we run in the short dimension, those floor joists are going to be loading those floor loads on that garage door header. And I think that initially we want to consider that that's probably not a great idea. If we can run the floor joists parallel with that garage door header, then all we're going to end up with for floor load on the header, just a small load, like a 1 foot wide trib load on this because of the first joist bay, and then of course there will be a wall above. But those are the only additional loads, because we're assuming that the trusses will be running in the same direction. We might even be able to reuse the trusses if they're not messed up too bad. And so the trusses will be continuing their same loading on the garage door header. So again, what we'll be adding to the garage door header load is that small floor load, if we can run those joists along the long axis there, and the wall load. So that's one of the first things we want to do is make sure that we can run joists along that 24 foot span, and that's going to work for us. So what I'm going to do is go into my browser here, and I'm going to type in bccalc.com. Already populated it because I've been there before, and hit enter, and it'll load up the Boise Cascade software, which is really pretty neat. I'm going to get rid of this one that's already there. Actually, yes, I do. Okay, so this is our splash screen. Tells us click on something to do something. So we want to look at our floor joist. So I'm just going to click on the new joist, and I'm going to just double click this guy, and that will open up our actual joist design software. It's processing. So here we are, and our default span is 14 foot. We're going to change that to 24. Okay, and hit tab. Enter it in. Hit tab. This is where we look at our supports, B1, B2. Support types of wall plates in both cases. Support material will be Douglas fir. We don't really need to enter that in, but it's kind of a good thing just to have it in there because that's what we're thinking. Support width defaults to 3.5. Our actual support width is going to be 5.5 inches because that's what the thickness of our wall for that existing garage. Accessory width, nothing there. So those are our initial spans. Our settings, we're going to take a look here at settings and let's see. Well, we're not going to worry about a maximum depth of our joist right at this point in time. I'm going to take a look at our subfloor material. We can assume it's going to be OSB, which is typically heavier than plywood, so let's go with our worst case scenario. Our thickness, let's have that at, start out with 7/8. We can go to 1 1/8 if we want to, or but let's just go there. Performance modifier, gypsum ceiling. We're definitely going to have 5/8 inch gypsum ceiling on that. Once those trusses are taken off and the floor joists are installed, we're going to have sheetrock ceiling. Live load deflection, that's the basic, the code allowance at L over 480. And everything else here looks good. Loads, we're not going to have any additional loads at this point in time. This should basically we have our 40-pound per square foot live load and 10-pound per square foot dead load. This is assuming that the joists are on 16-inch centers. We don't know that yet, but that's a fairly good assumption. That's a long span, 24 feet, and if we can get away with a joist that's the 11 7/8 inch depth, then it's probably going to be an expensive joist because that's a pretty good span. But that would be really good for actually several reasons. But so to see if this is all going to work, let's go ahead and take a look at products and click on that. And as it populates, so I'm thinking, so this is where we can modify our on-center spacing if we want. We can even do a best analysis if we want to, but and we can include rectangular products, versatile lambs, that sort of thing if we want to. But what I'm going to do is I'm going to go with the BCI 90-2.0 Douglas fir because that's a really beefy eye joist. We know that we want to just do a single ply. We're going to try the 11 7/8 inch initially. And so we're not going to worry about holes at this point in time. So we have up here, you can see it in the joist, a single 11 7/8 inch BCI 90-2.0. And so now I'm just going to run this, and you go up here to this icon, the little check mark icon, and you see it says Analyze Member. So I'm just going to click that and see what it says. It's running it, and that's good. It looks like we've passed everything. We're in the green over here. Floor value is not fabulous, but it's not that bad. So our live load deflection, which is really a measure of bounce, for lack of a better term, is L over 560. I'd like for it to be higher than that, but it's an accessory residential unit, and so a little bit of floor vibration, and this is actually going to be still a well-performing floor, is acceptable for us. So so now we know that we can run those joists at 16 inches on center in the long 24-foot span direction. So I think I'm going to go ahead and see if I can figure out how to save this. I'm going to go up here to save out summary. Let's see, I want to do I know what I want to do before I do that is I want to take a look at, well, I'll do that in a minute. I'm going to go ahead and save. It should bring up a dialog. Maybe we need to try that again. Okay, it's already, there was already a number assigned from when I was here before. Okay, so let's go save that again. Okay, now I'm going to take a look at the analysis, and that's this one, the member report. I'm going to click on that, and that'll populate and come up. And here we can see our report. It has that file name D0604UFJ-1, which is up here. UFJ's upper floor joist 1. We see our 24-foot span right here, and here's all of our percentages of allowable. The closest one is 85.7 for our live load deflection, but again, that is acceptable to us. So So I think we're in good shape as far as the joists are concerned. So I'm just going to go ahead and close this report right now. Most of the time I would go ahead and print this to PDF, and maybe I'll go ahead and do that. Print in PDF there, and I'm going to go ahead and tell it print. It should give me a location to, yeah, there we go. Okay, so I'm going to go down to C, and then down to projects. Double click that to open it, D0604. I need a new folder, and I'm going to call that structural. And then open that one and do another new folder and call it calcs. And open that one and do another new folder and call it floor beams, upper floor beams. Open and save. Okay, so I'm not sure what the name I get, but I'll go in and change that in a moment. I'm going to go ahead and close this down. Okay, I'm going to go into the actual folders, calcs, upper floor beams, and I'm just going to change the name of this report to D0604 UFJ-1. Okay, so we'll know what that is. So now we know that the floor joist system will work with 11 and 7/8 inch deep BCI joists at 16 inches on center. Those joists aren't inexpensive, but that's a heck of a lot cheaper than tearing apart that garage door header. Now we still need to make sure that that's going to work. We know that we don't have to deal with floor loads, but we are going to have wall load. So what we need to do is to take a look at that entire situation on that garage door header. Now, one of the things I want to do here is take a look at these drawings again, and I'm going to scoot out here a little bit. And so at the roof plan, we can tell that we have 2-foot eave overhangs everywhere. Okay, so I'm going to go back to the floor plan and bring that down. And so that means that our eaves, so we have 22 feet here, so half of that is 11 feet, that's our ridge, or our breakover point for the roof, and an additional 2 feet. So as far as the loads that existing header is dealing with, I'm going to go into my spreadsheet here, and you can use this spreadsheet in Google Sheets or Apache OpenOffice, either one, or Excel if you have it. So I'm going to go to New, my templates, and I want a calc sheet. Here we are, right here. Okay, job code is D0604. Member is D0604. And we'll call that UFB1. UFB-1. It's an upper floor beam. And it's a beam. I'm just going to mark that. And it's actually a floor beam now. It's going to be a floor beam. Location D0604 UFB-1. Okay, I actually should put existing. Okay, member length. Let's go back to our drawing here. So it's a 16-foot garage door, and we can see here that we have double trimmers at each end. So each one of those is going to be 3 inches. So it's the whole overall length of the beam is going to be 16 feet 6 inches. So let me click there, and it's 16.5, and span is 16.5. And bearing locations are 0, and tab and 16.5, and so there's the whole enchilada. I'm going to go ahead and save this file, save as, and I'm going to save it in our structural calcs, upper floor beams, and it is going to be D0604 UFB-1 calc sheet 1, and we'll save. Okay, so I just realized that when I saved that joist, I saved it in upper floor beams, and it should be an upper floor joist. So what I'm going to do is I'm going to go into Explorer here and create a new folder. New folder for upper floor joist. Okay, and then what I'll do is I'll move this upper floor joist into that one. That's where it goes. Okay, so get this down. So now we have our calc sheet for upper floor beam. So this allows us an easy way to total up what our loads are for that beam. So first of all, we'll just deal with the existing roof, but usually we're going to basically be moving that roof up 1 story. So we're just going to say roof, and type is uniform, and begins at 0 and ends at 16.5, and live load. Okay, so the live load is going to be 30 pounds per square foot. That's usually what I use for Ashland. Code will allow me to use 25, but I prefer 30. We've had some pretty good snows in the past, so we'll err on the side of caution. So we're going to take another look at our garage here. I'm going to scroll out just a little bit. So our trusses are going to be spanning a short direction, and we know we have a 2-foot overhang, so we have our 11 foot is half span and then another 2 foot of overhang, so that's 13 feet total that this header is going to be dealing with. So just a really quick and simple way to deal with that is our live load will be, we'll just go ahead and do a little formula there, equals 13 times 30, 390, and our dead load is going to be equals 13 times 20. That's what I usually use. So that gives us what our loads are, and load type is PLF. That'll be pounds per linear foot. And the duration, because it's a snow load, will be 115. Okay, so next we're going to have a wall load to deal with. And so the wall load, I'm going to open up another spreadsheet here. New, templates. Go down here to wall loads. Wall weights. Okay, wall weights. Okay. So for an 8-foot wall, we know that our actual wall will be 8 foot and 3/4 of an inch, so that would be 8.0625, and that will slightly change these loads. So and this is, we're going to be using hardy plank on the walls, and so by the time we have our subsiding and siding and all that, all those loads, that's going to come to 68.63 pounds per linear foot for the wall load. So I'm going to click on that and Control C, put it in the clipboard, and go back to my other spreadsheet if I can find it. There we are. And I'm just going to, and that'll be a dead load, so I'm just going to put that right here. Okay, and that is going to be wall uniform 0, 16.5, 0. That's also is PLF, and that's going to be 100. Could be 90 depending on who you ask. Okay, last but not least will be the floor. And that will be uniform also, and it'll go from 0 to 16.5. And it's going to have 0. It's going to have a live load. Now we're going to, even though our joists are spaced on 16-inch centers, the Boyd's Cascade design software won't let us go below a foot, so I'm just going to put 1 foot or our wall, or I mean our floor load will be 1 times 40 pounds. So we'll just put 40, and our dead load we're going to put 10, and that's PLF also, and that would be 100. Okay, so what we can do is we can total these up, and that makes it real simple to. So I'm just going to do a total down here. U 0, 16.5, and here I'm just going to do an auto sum. But before I do that, I probably need to unprotect the sheet to make it allow me to go back to home to make changes there. So I'm just going to click on these and hit tab, and that's our total live load and dead load. I'm going to go here and auto sum that, and then I'll go down like so and tab. That'll be PLF. And duration doesn't matter, let's put 100 for now. Okay, so now we have our information for the garage door header. We have the existing roof load that we already knew we had, the wall, and the floor. So we're going to deal with those, and this is the totals for those. So we have 430 for live load, and we'll call it 339 for a dead load. So I'm going to go back to our BC Calc software. This time I'm going to tell it I want to do a, here it is, new floor beam. It'll come up shortly. Okay, so we have new floor beam, nothing selected. So our span is 16.5, and it automatically changes it to feet, inches, and eighths. We have B1, B2 again, and in this case we don't really have wall plates. We have columns, and the same here. And support material, Douglas fir. And Douglas fir, and support width, that's actually 3 inches, so we're going to call it 3 1/8. It's as close as we're going to get. And accessory width, we don't care about any of that, so all that looks good. Our settings, tributary width, so I'm just going to put this at 1. Okay, and tab, and maximum depth. We're not going to use maximum depth. It's going to be dry, and usage will be a floor beam. Fixed live load deflection. We want more live load deflection than that, so I'm going to go at least 480. Let's see, total deflection, we're okay there. I'd probably go 360. But not going to worry about it at this point in time. So additional loads, we're going to add some loads, and we could go through and add each one. We could probably omit that floor load, but I'm going to go ahead and just leave it in. And go back to my spreadsheet here, and so live loads are 430, and dead loads are 339. So I'm going to go this type of load. Combine. And goes the whole thing. Okay. So this will be 430 and 339. Okay, roof live snow. Okay, so we don't deal with any of that. Okay, I'm going to go ahead and save. So we know that our beam is a, actually let's check that out. Look at our PDF here. Okay, so note 42 will tell us what it is. I'm going to scoot over here to it. To note 42, it's a 5.5 inch by 13.5, 24 FV4. Okay, so back to our Boise software. We've added our additional loads. You can see them now. Both our live and new dead loads. So now we're going to look at products. And we're going to go down to see what they have here. Series. We're going to look for glue lamps. Aha! Here we are, glue lamp beam, 24 FV4. That's us, right there. And our depth is 13.5. That's here. And so ours is actually 5.5. They're saying 5 1/8. Apparently that's what they have for the Boise Cascade series still. And so now we have all that stuff selected. Let's just click on see what happens. Looks like we're good to go. The moment is 81.8. Live load deflection is 85.5. So we're good. That existing beam will work. We'll also need to go through and check to make sure that the existing footings are going to work, and the existing columns and all that. But it looks like we're good to go. So at this point in time, we're good to go structurally. I'll need to check those footing sizes. We'll look at the we'll look at the existing drawings to see what those are and check those out later. But it looks to me like we're good. We could enlarge those footings if we needed to, undermine them, and hopefully we won't have to do that. So anyway, we know now that we have a green light still to go forward with this project structurally. So that concludes our Dcad lesson 18C. Still dealing with project evaluation. We'll be moving on to design here very quickly.